Alright, so let's get started on review of word problems. It's on page 357. As you guys said, you thought it wasn't difficult. So let's just start with the first problem. Go forward from there. Number one. Number one says, two houses are for sale on the same street. Right? So come and read along with me. So it's good if we can stay together. Two houses are for sale on the same street. The second house has 1,000 square feet less than twice the square feet of the first house. Okay. So together the houses have 4,400 square feet. What is the square footage of the first house? So the most common thing you're going to do with these kind of problems is you need to decide what is your x. Right? What is your unknown? And often they're giving you like two things, and one is related to the other one in a certain way. And so what you need to do is, whichever one is like, if something is such less than another one, or twice another one, or something like that, then the other one is going to be your x. Right? Because it's whatever you're modifying, then the original will be the x. So this one it says, the second house is 1,000 square feet less than twice the square feet of the first house. So this means the first house is going to be x.
Yes.
Because the second house is some combination of modifications of the first house.
Yeah.
So if we make the first house x, we can write the second house in relationship to the first house. Okay, so that's how we're kind of doing it. So first house will be x. Okay? And the second house, what does it say? It's 1,000 less than twice the square feet of the first one. So what is twice the square feet? What's twice? 2x, that's right. 2x, and it's 1,000 less, right? So minus 1,000. And this is our essential step. Right? We write 1 as just a plain variable. You don't have to use x. You can use whatever you want, but x is the most common, right? So you write your first one as x, and the second one as some combination of changes related to x. Because you want to have only one variable from these. Because now, it says that both together, right?
Yeah.
Together, they equal 4,400. So first plus second equals 4,400. And now since we know what the first is and the second, we put those in. So it becomes x plus 2x. Yeah, brackets is probably better. Because it may be some other thing. Equals
4,400.
Okay, does everyone see what I'm getting here? Right? I'm just taking from this. It said the second house was 1,000 less than 2 times the first. So that's how I got these two x's. And it says together they equal this. Now this might be something else. Maybe it's some minus, some other combination. But this one we know they added up to 4,400. So therefore we know this plus this, which is first plus second, equals 4,400. So now we have an equation and one variable. So we solve the equation the way we know.
Yes.
Alright? So first we just need to simplify this one, right? So this is going to just be, I'll just simplify, take away the brackets, so 2x minus 1,000. Alright, so first of all, what are we going to do? Add the x's, right? 3x minus 1,000. Okay, then we need to get rid of this 1,000, right? So we add it to each side, right? So therefore 3x equals, as you said, 5,400. Alright, now how do we get x by itself?
Divided by 3.
Divide by 3, that's right. So we're using what you learned earlier for these problems. Okay. 1,800, yeah? Alright, and was the problem, now the question is, now you have to be careful, because you solved for x, but that isn't necessarily what the problem is. Is it also for the first house or the second house? If it's the second house, you have to put this back in here.
Yeah.
So what does it say? What is the square footage? First house. Okay, good. Here we have x, which is this one. And then the second one would basically be
3,600
3,600 minus
1,000.
2,600.
Yes, 2,600.
Yeah. All right. Any questions on this? How I did this? Step by step. This is how these problems go. You don't jump to the end. You do step by step. And now we can check it if you want, right? Because we said 1,800 and this was 2,600. You add them together, it becomes 4,400. All right. Let's do number 2. Number 2, they give you a hint, right? Which is nice. All right. Julia has 24 coins in her pocket. The coins are either dimes or quarters. Do you know what a dime is? Or a quarter? This is where they're going to trip you up by not being American. Not quite dollars. It's cents. So, a US dollar, that's $1, right?
Yeah.
And it has 100 cents. So, 0.01 equals 1 cent, like that. Okay? So they have 1 equals 1 cent, or a penny. They call it a penny, it's the coin. Alright? Then 5 cents is a nickel. Okay? 10 cents is a dime. 25 cents is a quarter. That's pretty much, you have 50 cents, they call it a half dollar. So the reason this is a quarter is because it equals 1/4 of a dollar, right? 25 cents is $0.25. They call it a quarter because it's a $quarter. Right? It's 1/4 of a dollar. They don't call this a tenth of that, they just call it a dime. Although I think deciliter, it might be related to like deci, which is a tenth. In Latin. Nickel is just because the coin used to be made of nickel, so that has nothing to do with the value. But you may see these words, and they would expect you to know them because every American child, learns these from age 5, right? But you guys aren't necessarily familiar with American currency, so you need to trip up a bit. So it says it's a dime and quarters. Okay, that's useful to know. So let me just erase these. Okay, so we have 24 coins, and they're either dimes or quarters. All right. And the total value of the coins is $4.50. So how many coins are dimes? All right, and then it actually gives you a nice hint. All right? It says dimes are 0.10, 0.10x. Because that's the value of it, right? If I have 8 dimes, then I have $0.8.
Yes.
And then if it's the quarters, the value of the quarters, you want to write it in terms of the other one, right? So this is the simplest one. So this one is now, we know there's 24 total. So yeah, 0.25 times however many quarters we have, right? Which is 24 minus x. So this is a nice hint that they've given you. If they hadn't given you the hint, then what you'd want to do is you could say dimes, number of dimes is x, and number of quarters,
0.25.
yeah, quarters is 24 minus x, right? So that's always how we start. We always start with let's find one variable, We could have done it the other way around. Actually, this problem would work out if we do it the other way around. If we say quarters is x and dimes is 24 minus x. But then we'd have to change the value, right? But it would still work out. And if you want, I can show you that way as well. But we would start with this, and then we'd say, well, we know we're trying to get the total value, right? So then we'd say times 0.1 times 0.25. And now what does it say? How much is this all equal? 450. Right? So the value, so we'd say the number of dimes is 10, is x. So the value of dimes is 0.1 x plus 0.25 times 24 minus x. This is a quarter, so this is not the value of each one. So we started here, but then we have the value of each one equals 4.5. Okay? Because we know this.
Yes.
So I'll put dollars in front of it to make it easier. Okay? The dollars, because this in dollars equals the total. Okay? But it's nice, they gave this one to us, so we just have to solve it out here. So now we have to solve it. So first of all, we have 0.1. I'm going to lose the dollars from this point onwards. So 0.1x plus, now we have to solve this out, right?
Yes.
What's 0.25 times 24?
It's 35.
Not quite.
Ah, okay. Yes.
And how do you get 6 so quickly? Pardon?
No. We can must multiply.
Wait. Okay. Yeah. So what were you going to say?
Is we must say 0.10x plus we multiply 0.25 times no actually.
Yeah, so let's just do this one. 25
Yes.
plus 24.
Yes.
What you were saying was you said we do 12, that becomes 50. And then we do 6 and it becomes 1. One other thing you can do is 0.25 is a quarter. So what's 24 times a quarter? Is 24 divided by 4,
Yes.
which is 6. Like a quarter of
0.25x.
Yes, this is the same as 0.25 times 24 equals 1 over 4 times 24. Right?
Yes.
Remember, you convert your decimal to your fraction.
Yes.
And then you can cancel that. That's 6. Both would work. What you were actually doing in your head kind of was that, because you divide by 2 and you divide by 2 again. Which is the same thing again. Okay, so this is now 6. So 0.1 plus 6 minus 0.25 x equals 4.5. Alright. So now we're going to have a problem. Right, we're going to have some negatives. So the first thing, let's add these two. Right, what's 0.1x minus 0.25? 0.15, exactly. It's 0.1 minus 0.25. The difference is like 25 minus 10 is 15. Alright? So that equals negative 1.5. Alright, so this becomes, negative 0.15. Another way, which I think one of you is thinking, is you just multiply the whole thing by 100, and then you go to decimals.
Yeah.
Right? Because you multiply 100 on this side and 100 on this side. Right? Because whatever you do on one side, you can do the other. But I'm going to keep it in decimals for now. There we go. So this becomes negative 0.15x plus 6 equals 4.5. Alright. Now we want to get the x variable by itself. Right? So you have to get rid of this 6. How do we do that? Sorry. So we subtract 6 from each side. Alright, so now I get 0.15. And what is 4.5 minus 6?
1 minus 1.5.
Minus 1.5. So Like the 6 minus 4.5 is 1.5. The 6 is negative. So that equals negative 1.5. Oh, this is, sorry, there's an x here. Now I want x by itself. What do we do?
We divide by minus 1.5.
Yes, by minus 0.15. So divide by negative 0.15. And this one's divided by negative 0.15. So this, they will cancel and we get x on this side, right? Because negative 10 divided by negative is positive. And here, 1.5 divided by 0.15. 0.10? 10? It's 10. So I'll show you.
Yeah.
So we have 1.5 over 0.15, right? That equals 15 over 1.5, right? We're just moving the decimal. Basically multiplying by 10 over 10, right? That equals 150 over 15, okay? And this one equals 10. You see that?
Yes.
So if you ever have, it's the same exact digits, but this one, the decimal is 1 further than the other one. This means this one is 10 times this one.
Yeah.
Right? If I multiply this by 10, I'll get this one.
10.
So this is 10. So x equals 10. Is that our question then? How many of the coins are dimes? Yep, x is dimes. So 10. There we go.
10 times.
And how many quarters?
Out 10 times. What is 24 minus x.
So how many quarters?
14.
14 quarters.
Yes.
Right? So 10 dimes. The first dime is 10 cents.
Yeah.
So that means 10 dimes is $1, right?
Yes.
14 quarters. Every 4 quarters is $1, right?
$1, yes.
So 4 is 1.
Yes.
8 is 2.
$3 and 50 cents.
12 is 3.
Yes.
And 2 more is 50. So
Yes.
350 plus 1 is 450.
Okay.
So it's right.
Yeah.
That's how you check it. When you double check it, you know for sure.
Yeah.
Actually, my dollar here is a little bit hard to see. And I'm going to take a picture, and then I'm going to try to do this problem. I'll leave it up here, and I'll do it the opposite way, just so you can see it still works. Oh, wait. This is erase number 1. Remember I said we could say dimes are x and quarters are 24 minus x. We could do it the other way around. Okay? So we could say quarters, and just to keep it clear, quarters are y, okay? And dimes, therefore the number of dimes is 24 minus y. Because if you tried this problem and they didn't give you this, you could actually, in this one you could choose dimes or quarters as your main variable. Just as long as the other one is in relation to second. So you say this is y, so you choose your variable, and you find your other one is relationship to it. So 24 minus y. So then what we're saying is the dollar amount of the quarters equals 0.25 y, right?
Yes.
Because that's how I have quarters. And then the dollar amount of the dimes equals 0.10 times 24 minus y. Because now we're doing dimes. It's kind of the inverse of this. And but still equals 450. So that means 0.25y plus 0.1 times 24 minus y equals 4.50. Okay? Same thing, 0.25y. Now we multiply this. What's 0.1 times 24? What's 0.1 times 24? 0.1 times 24. 1 times 24 is 24.
Yeah.
So 0.1 times 24, it's the inverse. It's 24 divided by 10. Yeah. So this is 2.4. Right? And if you remember, we did long division. Do you remember when we did long division? Yeah. Right? I would do 2, 4, and I'd count how many decimals. It would be 1, so I'd put it there. Okay? If you ever have 0.1 times something, it just means move the decimal. It's like 1 times it, but with a decimal. Okay, so that equals 2.4. So plus 2.4 minus 0.1y, right, equals 4.5. Now we add the y's. So 0.25 minus 1 is 0.15 y plus 2.4 equals 4.5. Right? I hope this is right.
Oh.
I feel like you're going to get in trouble. Something's wrong.
But let us finish first.
Yeah, no, I'm doing something not quite right. Yeah. No, yeah. No, it'll work. I'm just doubting myself. So we subtract 2.4 from both sides, right?
Yes.
Yeah, I was thinking the same last night and I was upset about it. Okay, so if we subtract 2.4, 4.5 minus 2.4 is 1 and 2. 2.1.
Yes.
Divide each side by 0.15. You'll find that y equals, this is the same as 2.1 over 0.15 equals 210 divided by 15. So just move the decimal. Okay? So we have a common 5 in each one, right? Actually, there's a common 3 in each one. That's the easier one. 21 is 70. Alright. And then you can see there's a common 5, and that's 14. So y equals 14. So if y equals 14, then times equals 10. Which is the same we got here. So you actually come to the same answer from 2 different ways. I just wanted to demonstrate that. If they hadn't given you this, you could have done it either way, you still would get the same answer. But fortunately with this one, they did give you the easy one, the beginning part. Alright. But each one is some work. It's some work figuring it out. But these are more like real world problems. Since I think nobody did the WhatsApp questions, I'm not going to do any review of them. I'm going to encourage you to do it again tonight, this week. Okay?
Okay.
So you can have some practice with those. But I will do some more from page 357. So let's see here. We can do number 3. Well, no, number 3 is a bit like number 1. What I'll do, you know what? I'll set it up, but I won't solve. Okay?
Don't do it number 3
Here's how number 3. Okay. So number 3 says the bulldogs won twice as many games as they lost. What do you think it means by the Bulldogs? What are they referring to here?
Dogs, right? Dogs. A kind of dog.
It's a kind of dog,
Yes.
but in this one it's probably a sports team.
Yes.
It's a sports team called the Bulldogs. America, they like to name teams after things that are aggressive.
Yeah.
They have like the Patriots and the Seahawks and the Colts and the Buffalo Bills. So the Bulldogs. So they won twice as many games as they lost. If they played a total of 36 games, how many did they win? So that means we have win, won, and lost. These are our two things that we have, right?
Yes.
So we need to decide which one is going to be our variable. It says they won twice as many as they lost. So that means the lost is like the playing. Right? Lost is the one that's just
Lost would be.
so lost can be our variable, x.
Yes.
Because then 1 can be 2x.
2x, yes.
Right?
Yeah.
This is the essential step. This step right here. You look at what you have, and you write in the two things in terms of one variable. And so you're looking at it, they won twice as many as they lost. So win is 2 times this. If you wrote it the other way around, it would basically be like y and 1 over 2y, which is more confusing. Right? You could say they won, this is 2 times what they lost. If you insist on this one being a variable. But I think it's much easier to do sort of, if it's saying something modifies something else is your main variable. And then you write the first one according to how it was modified, how it was changed. So for example, in the first one, we have the second house is 1,000 square feet less than twice the square feet of the first house. So here we have the second house is all these changes on the first house. So we make the first house our variable, and we write the second house according to those changes. Same here. We have wins and losses. And the wins are 2 times the losses. So we say the plain one is the variable, losses, and win is 2 times. And now, we can look, they have a total of 36. So this, number 1 and number 3 are pretty much the same kind of problem. So total equals 36, right? So 1 plus lost equals 36. Now 1 is 2x, so 2x plus x equals 36. Everyone see that?
Yeah.
And we just solve for x. It's nice to say there are no tied games. So what happens here?
3x.
Becomes 3x equals 36. Now how do I get x by itself? Divide by 3, that's right. Divide by 3, divide by 3. And I get x equals, what was that? 12, that's right. Alright, x equals 12. Is that the answer?
No.
No? You read the question, right? This is the problem with doing it this way. Sometimes you'll choose the simple one,
24.
but it's asking for how many 1,
2x.
right?
Yes.
So we solve for x, but the 1 is 2x.
Yeah.
Right? The win, or 1, equals 2x, which equals 2 times 12, which equals 24.
Yes.
Okay? So read the question, be careful. So 24, and if you look at it, so 24 plus 12 is 36,
Yeah.
so combined is 36, and 24 is twice 12.
Yes.
So there we have it. Some of these questions you can probably just figure out in your head without doing the algebra. And in fact, a little bit later, I think in next week actually, we will do how to do that in your head. We'll cover that. Because there are some ways you just kind of think about it.
Yeah.
And the reason why that's helpful is it's a way to know that your algebra is correct. Kind of figure it out in your head as well. Any questions on this one? Does that make more clear? You want to know? Yeah?
I don't have problem with the equation, but I have to work on how to get out of the equation.
I know, that's the challenge,
Yeah.
right? You guys can do, once we get here, you can do the math.
Yeah.
Yeah, that's great. Actually, first of all, stop and pat yourselves on the back. Good job, you can do the math. We got to this point where you can do these algebra equations. Well done. So don't dwell on how hard it is to get the math from the word problems. First of all, you know how to do the math. That's excellent. You've come to this stage and you're able to do this. All right, and you say this is easy. This is what you're telling me. This is easy.
Yeah.
That's good. I don't think two months ago this was easy. So it's good. Right? So be like encouraged. Okay? But yes, this is the hard part, the word problems. And it's difficult. You have to practice. These kind of things, it takes a lot of practice.
Yeah.
And that's why I said, usually, with this kind of thing, the first thing you figure out is what is my variable? What is my x? Okay? And when you say, what is my x? You look at this thing and what it tells you. Like these kind of problems, it has two things. First house, the second house. Wins, losses. Dimes, quarters. Always like these two things. And one of them is in relationship to the other one. And it tells you the relationship. It says it's 1,000 less than 2 times. It's 2 times. It's together they're 24, so it's 24 less than this. And so when you write them, from that you take the simple thing, the one that's being changed by the other one. That's your variable, the first one, or the second one, whichever one it is. But the simple one is your variable. And then you write the other one in terms of that variable, which is just given you. It says 2 times. So you write it in terms of this variable. And then, once you have these two written out, then you can figure out, often they combine together to something else. So you write what they combine together, and then you put each one in, and then you solve. That's kind of the pattern of these word problems. Let's try to do another one. Number 4 is the consecutive number one. Remember we did this last week. I'll go over this one again. So it says the 4 consecutive numbers. Oh, how do I spell it?
It's even number.
Oh, let's see. It's consecutive even. I'm just going to write the symbol numbers. Okay. So that means it's 2, 4, 6, 8, something like that, right? Mm-hmm. And it says the sum. The sum means they add up, right?
Yeah.
So sum equals what? 212?
212.
212. Okay. So in this one we have consecutive even numbers. It means you have 1, the next one is 2 more.
Yes.
Next one is 2 more. 4 is 6. So we start with x. Right? That's our simple, it's kind of the same. Start with one variable, and the rest are in relationship to each other. So we have x plus, well, let me just write them all out first, okay? So we have x, then x plus 2 is the next one, right? 4, x plus 6. They're even, so they're every 2. Right? So x plus 2, x plus 4, x plus 6. And these 4 added together equal this. So we do x plus 2 plus x plus 4 plus x plus 6 equals 212. Alright?
Yeah.
Here's our equation. And we solve it. So how many x's? 1, 2, 3, 4.
4x.
4x. 2 plus 12 equals 212. Alright. Now we need to get rid of this one, right? That's right. Minus 12 minus 12. 4x equals
200.
200. Now I want x by itself, right?
50.
Divide by 4, that's right. That's right. You guys got that. 50. There we go. X equals 50. Now that's the question.
Yeah.
No. That is not the answer.
There is no answer, yes.
It wants to know what is the third number. Alright? So this is the first, this is the second,
Yes.
this is the third. So,
First number.
that's x, let me put third
Third?
equals x plus 4, which equals 54. Yep, 54.
Yes.
I guarantee you, in the multiple choice, one of the answers will be 50.
Yeah.
They will try to trick you.
Yeah.
One will be 50, one will be 54, one will be like 6, and one will be 172. There'll be two that are like a challenge.
And the second become 52.
Pardon? Yeah, so the second is 52. So this is first,
First is 50,
second,
52, 54,
third, and fourth.
56.
Yeah. And then there's consecutive even. 50, 52, 54, 56.
Yes.
This is how you do these kind of numbers, these kind of problems. It's still there's still a basic similarity in that you find what's your variable, and you write all the other things you had in relationship to that variable, right? Because these are what you call single variable equations. So that will go on. Right, any questions on these? Not, I'll move on. Now, I'm not going to have time to do all of them. Just do a few more. Nothing to consecutive one anymore. Of 5, 7, and 8, which one do you guys want to do? What is this one? Number 8? 7? 7 and 8. Okay, let's try number 7. So, number 7 says, in a month, Andrew spends twice as much on rent as he does on food for his family. Last month, he spent $1,650 on rent and food. So it's the same kind of problem. You have two things. One is in relation to the other, right? So we have rent
Number 3.
and food. Okay? And which one is in relationship to the other one? Which one's the simple one? The rent or food?
The rent.
Because he spends twice as much on rent as he does on food.
The less is food.
So food. Food is the basic, and rent is 2 times food, right?
Yeah.
So that means food is x, and rent is 2x. You guys see, this is the pattern.
Yeah.
This is why we do this multiple times, we start seeing the pattern, we see how we do it. So food is 2x. Alright, and now we know that combined together they're 650, right?
1650.
Rent plus food equals 1650. Alright, then we put them in. Alright? 2x plus x equals 1650. This is very much like number 3.
Yeah, exactly.
Okay? It's actually the same format even.
3.
That's right, 3x equals 1650. Divide each by 3. X equals, what's 1650 divided by 3?
1.
We can do it this way if you want.
Yes. 550.
550?
Yeah.
Yeah. And that doesn't have. Yeah. There we go. 550. So x equals 550.
This is food.
Is that correct? Is that the answer?
Yeah.
No. Remember? Because they wanted to know rent. So if x is food, rent
Is 1,000.
equals 2x,
Yes.
which equals 2 times 550, which equals what?
1,100.
1100. And I'll put the dollar in front. Alright, everyone see that?
Yeah.
It's the same pattern.
Yes.
You find what's your simple one, that's the variable. The one that's like has changes on it, then you write it in terms of those changes, so they're both are in terms of one variable. Combine them, you solve it. Okay? Take a picture of that. And now we'll do number 8. Okay. George spends 4 times as much time helping customers as he does stocking shelves. Last week he spent 35 hours on the 2 tasks. So how many hours are spent helping customers? Okay, so this time we have,
X plus
I'll do customers is something, and shelves is something. Okay. So which one is the simple one and which one is being modified?
sure, the simple one.
You guys see that? Right, so it says he spends 4 times as much helping customers as he does stocking shelves. So it's 4 times shelves.
Yeah.
Right, so shelves is the plane. Shelves will be X, and customers is 4X.
Yes.
Alright, so it's 4 times as much time.
Yes.
Same kind of problem. Right, and now the total
35.
is 35. So customers plus shelves equals 35. Okay?
Yes.
So we do 4X
Plus X.
plus X equals 35.
34.
You guys see that? It's the same kind of pattern.
Yes.
Right? This one is the simple one, this one is modifying it,
Yeah.
and we solve it.
5X
So this becomes 5X,
equals 35.
35,
X equals 7.
Equals 7.
X equals 7, that's right. You don't even need to write divide, you guys know that. X equals 7. Is that what it's asking?
No.
No, because X is shelves.
Yes.
So customers,
28.
exactly, equals 4X,
Yes.
which equals 4 times
And 7.
7, which equals 28.
28 hours.
Yeah, so he spends 28 hours
Yeah.
helping customers and 7 hours stocking shelves. You see it? Same time. This is why practice is good. The more we practice, the more we see the pattern.
Yeah.
Right? And in some ways you can be shown, like you can look at it and someone can tell you the pattern, but until you do it, you don't really get the pattern. Because it becomes something almost intuitive. You don't even think about it. Right? Because you practice them. Alright, let's do some of these other multiple choice ones. Some of them are difficult. Let me take a picture first. Well, actually, no, that's space. Alright, actually, number 9 is a bit more complicated. Let's do number 9. Okay? Number 9 says Sylvia scored 10 points better than Wiley on the science exams. And Greg scored 6 points less than Wiley. So now we have 3. Instead of 2, we have 3. So we have Sylvia, Wiley, and Greg. Right? Which one is the simple one, and which one is being modified? Which one's being modified? So Greg scored 6 less than. So that means he's got something, some modification. Wiley is the simple one. Because Sylvia's 10 more than Wiley, and Greg is 6 less than Wiley. So Wiley's kind of like by himself.
Yeah.
So Wiley becomes the X. If we write X, then Sylvia is X plus 10, and Greg is what?
X minus 6.
Minus 6. Okay, do you see that? This is why I chose Wiley to be X. Because Wiley was the one that didn't have any less or more. They don't actually mention Wiley by himself. They say Sylvia and they say Greg. But we have Wiley in both of them. Which actually also makes me think if Wiley's in both of them, then he should be the X. Okay? And then it says their scores together are 226.
Yes.
So it's S plus W plus Greg equals 226. It's kind of the same sort of problem. It's just we have 3 this time.
Yeah.
So we add all these together. X plus 10
plus
plus X plus X minus 6.
equals 226.
226. Alright, so how many X's do we have?
3x
3X. And the constants add to what?
plus 4
Plus 4
is
equals 226. Alright, we're going to get rid of the 4, right?
yeah.
So you get 3X equals 222. Alright, I'll just put a little. Alright, now we want X by itself.
Yeah. Divide by 3.
Divide by 3. So what is 222? Divide by 3, right? It goes here 7 times.
Yes.
21,
7.
12, 4 times. Yeah. Okay, so X equals 74. Alright,
Now
is that our answer?
yes.
Hey. Wrong.
Really?
Wrong. These options is tricky.
Okay.
Read the question.
How many points?
It's Sylvia first. Right, we just solved for Wiley.
Yeah.
Okay.
84.
84, that's right. They're tricky, I'm telling you. They'll put that one in there.
Yeah.
So S
Good.
S equals X plus 10,
Yeah.
which equals 74 plus 10 is 84. Now this is not a test of your math. This is just a test of, did you read the question? And they're trying to trick you.
You're back, yeah, actually.
Because they put 74 and 78 and 84 and 94. So 74 is the one you would have gotten here. But the answer is 84. C. Okay. Did everyone see how we did this? The hardest part here is this part right here.
Yes.
Right?
This one.
This is the most difficult. Deciding what your X is. Right? Deciding which one is your variable. And always what I'm saying is you need to identify your different parts, your pieces. And your variable is your simple one. The one that's not having anything, it's not doing anything, it's not changing. No, like it's 2x this or something less this. It's just it's the same. And in this case, they were like saying it's hers is 10 more than Wiley. Because it's 6 less than Wiley. Right? So it's like, oh, okay, Wiley is the basic variable. We solve for that, and then we can get this one. Alright. Possible, these things you can't solve in other ways. Alright, so if you choose the wrong variable, it's not the end of the world, you just have to make sure your relationships are correct. Okay? So let me show you. Say we decide, no, we're asking for Sylvia, right? So X is Sylvia. I don't care, X is Sylvia, whatever happens. Okay? Oops. S, W, and T. Sylvia's X. Okay? And we know it says Sylvia is 10 more than Wiley, right? So that means Wiley is X minus 10. Right?
Yes.
And we know that Greg is 6 less than Wiley. So if Y is X minus 10, Greg is X minus 10 minus 6. Okay? So it's possible you can choose this one. Right? So it's not the end of the world if you choose the wrong variable. Okay? You just have to make sure that they're all in relationship to each other the proper way. Right? So you can make sure they're all related according to the way the problem is set up. Like for some of those others, where I said it was 4x and x, if you chose this one to be y, that's fine, but then this one has to be 1 over 4y. Because this is 4 times this one.
Yes.
Right? So it's still possible to solve it this way, but you have to make sure you just have the relationship between them correct. So in some ways, it's not the end of the world if you get the wrong variable here. Right? You can choose any of these guys to be the variable. You just have to make sure the others are related to them correctly. So I said, okay, x is by Sylvia. So I know that she's 10 more than Wiley. So Wiley is x minus 10. And I know that he Greg is 6 less than Wiley. So put Wiley, which is this one I did here, minus 6. And here I'll solve it out for you just so we can see what I'm saying. So now these all add up still to 226, right? So it's x plus 10 minus 6 plus x minus 10, big brackets, minus 6 equals 226, right? So x is here, Sylvia, Wiley, and Greg. Now I can get rid of these brackets because they're all just adding, subtracting. So it becomes x plus x minus 10 plus x minus 10 minus 6, right? Yeah. Equals 226. So these all still become 3x, right? Now it's minus 26 equals 226. So 3x, we add that, so it becomes 252. Or did you add them? Because 25 plus 25 is 50. So it's 1 extra, so it's 52. Divide by 3. X equals, I'll bet you this is 84.
84.
Try it.
Exactly.
252. 3 goes into that, 8. Right? 24. Subtract 1, 12. There we go. 4. And that's actually our answer. This is all still here. Right? So it doesn't actually matter. It's helpful. I like to do the simple one because it makes it easier to set up the problem. This is a little more complex than this. Right? Yeah. But it actually doesn't matter which one you choose to be your variable. So take that in your mind. Don't worry if you choose the wrong variable. Okay? Because you can still solve it. You just have to use your algebra. And you have to make sure, however, whatever variable you choose, the others are the correct relationship to that variable. Right? So if I say I choose Sylvia, then I have to make sure I set the rest of them up according to what Sylvia is. And sometimes if you find you're trying to do this and it's really hard to figure out the relationship, that might be clear to you to try a different one to be the variable. And so you can be trying this and be like, I don't know, this is weird. So okay, let me try y as my x instead. And then you get here, okay, that's a lot more simple. Let me use that one. You have to make sure that whatever you choose for your variable, it has to be like this. It has to be set up. You can make Greg your x, right? Then if Greg was x, Wiley would be x plus 6, and Sylvia would be x plus 16, right? And you add them together and you solve for x for Greg. The same method.
And how would it come with 10 minus 96? How would it become 8.6?
Because it's 10 here, and 10 here, and 6. So 10 is 20, and then there's 6. This 10 is coming from here.
Yeah.
This 10 is coming from here. And the 6 is coming from here. Right? If he's 6 less than Wiley, and Wiley is 6 less than Sylvia, then he's 16 less than Sylvia. Less than 16, but there's also 10 here, so it's 26. Okay, I think let's take a break, and we can do, maybe we'll definitely do 11. Maybe we'll do, let's do 10 and 11 both, just to make sure we get them. And if you guys want more practice, like I was telling you guys earlier, use Khan Academy. It's a great resource. You can pay for it, and they'll refresh. So you can kind of like practice and practice. Okay? Because these are ones that you really should practice. And like I said before, I am helping you, but it's on you guys to do the work, to practice. And I'm not going to be like, we're not in high school. Right? I'm helping you, but for you to kind of, to do your work to get it. Okay. Picture of that. Right, let's have a break. Here we go. Let's start. We'll do number 10. So number 10 says we have 2 adults and 4 children paid $48 to get into the theater. A child's ticket is $6 less than an adult's ticket. What is the cost of an adult's ticket? So we have child's ticket and adult's tickets, right? Yes. So So we'll
X
do
and X minus 6.
child and adult. Okay, so 1 is 6 less than adult. Okay, so if the child is 6 less than the adult, probably the simple variable is the adult, right?
Yeah.
So we do x,
X
and this one is x
X
minus
minus
6. If we did it the other way around, if we said child is x, then adult would just be x plus 6.
Yes.
It doesn't, it's not too big a problem. And then sometimes it helps, sometimes it's easier just to say, what am I looking for, make that my x. But sometimes it doesn't, because it makes it complicated.
Yeah.
In this case, it would be fine either way, and it works out nicely. So we have x and x minus 6.
48.
And now we have this, how many children? There's 2 adults
And 14.
and 4 children. Okay? And the total is 48. Right? So 2 adults and 4 children are paying 48. This is the second stage of the problem. It's a little bit more complex because the other types that we did, it was just whatever this was plus whatever this was. This time it's 2 times this and 4 times this. It's fine, this is kind of like a variable of its own, and we just substitute whatever it is in here, right? This becomes 2 times x plus 4 times x minus 6 equals 48. Right, do you see that? Because these are the prices. So 2 adult tickets and 4 children's tickets together equals 48. So now you need to solve it. So this becomes 2x plus 4x
minus 24.
minus 24 equals 48. Okay? 2x plus 4x
6x.
is 6x minus 24
Yes.
equals 48. Okay, now we need to get rid of the 24 on this side, right? Or this by itself.
Yes.
So we add, no, you can divide by 6, it's true, you can. But I find it's easier to get rid of the
Yes.
plus and minus first, and then you do the multiplication. So we add 24 to each side. So this becomes just 6x, 72. All right. Divide by 6.
That's quite 12.
That's right. X equals 12. Okay. And that was the question, right? It says adults? Yeah.
What's the cost of the adult?
You see, adults is 12,
Yes.
and children then is 6.
24.
And you'll notice that they give you both 12 and 6 as a solution. But this time it says adults, so it's 12. Right? And so if we have 2 adults, it's 24, and 4 children is 24, and 24 plus 24 is 48. So it's correct. So that is B. Any questions on this? It's slightly more complex.
In the other case, if you ask for the...
So if you ask for the children, I say 12, the child adult is 12, the child is x minus 6, so it'd be 12 minus 6, and then be 6. Yeah. Because once you have the relationship between them, if you find what the variable is, you can easily find whichever one you want, even if it's not the one that's just the variable. Yeah. All right. Let's see. Number 12. Now I looked at this one. This one's a more complicated one. What's nice is they give you this table to help you with it. It says Jenny is 4 times as old as her niece Tina. Okay? In 12 years, Jenny will be only twice as old as Tina. The chart shows expressions for Tina and Jenny's ages now and in 12 years. So how old is Tina now? So the first thing we can do is Jenny and Tina, right? Okay, so which one's the simple variable? Tina, right? So Tina is x, and Jenny is 4x. Alright, so this would be like fine, normal this way. Except now we don't have an easy equation. Instead it says, in 12 years, it's going to be there'll only be twice, right? So it says in 12 years, Jenny, as busy on the table, will be 4x plus 12. Okay, makes sense. This is now, this is then, right? And Tina will be x plus 12. Okay. And what it's telling us, so we already have this, and it tells us this, and says she's twice as old. So that means in 12 years, this, Jenny, equals 2 times Tina. Okay? In 12 years. But now we know what they are in 12 years, so we just put it in for each one, right? So it becomes 4x plus 12 equals 2 times x plus 12. Right? Now we have our equation. This is the hard part. Now it would be much harder if they didn't give you the chart. Right? They just said in 12 years, and now solve for Tina's age. You'd have to figure out, oh, in 12 years, this is the ages with times 2. They give us the chart, so it helps us to get here. This is the key, how to get the equation. This here is the same as this one here, right? So we know their relationship, and we have an equation. We put them together, and now we have only x. We can solve for x. Okay? So this is 4x plus 12. Can you multiply this out, right? 2x plus 24. I'm going to take a shortcut. I'm going to do it at the same time. Move x here and 12 here.
Yeah.
Okay? So 4x and 2x. I'm subtracting 2x from each side. So this becomes 2x. And here I subtract 12 from each side.
Yes, equals 12.
Equals 12.
X equals 6.
This is how I always do it in this way, the shortcut. I've been doing it more slowly so you can see what I'm doing. But this is kind of a quick way to do it. Like whatever's, move the variables onto this side and the constants onto that side. Okay, so we subtract 2x here, and we add 12. Or subtract 12 as well. Okay, now x equals 6, which is Tina. And we can test it, right? So, right now, she's 4 times. So Tina is 6, Jenny is 4 times 6, 24.
Yeah.
Right? In 12 years, Jenny will be 24 plus 12 is 36. And Tina will be 6 plus 12 is 18. And 18 times 2 is 36. So it works. Alright. So that's a complicated one. It's nice they gave you the table. Alright, so let's do our lesson. I'll leave the WhatsApp for you guys to try, because I think it's good to have more practice. And again, I encourage you, use Khan Academy to practice these as well, because a lot of practice will help. I think you saw as we went through them, there's a kind of a pattern to how we do them. Yeah, it is a bit empty. Okay.
It's fine, they also have teams, but they're not comfortable enough to lots of over the website.
Okay.
But it's not a responsibility, but just so you know that I must.
Okay, so should I check to them when I leave?
Up to you, like they have teams, but
Okay.
how to use English is very unsure about it.
Okay, well, okay.
Maybe you're here until 9 and then you're leaving.
Yeah.
They're not expecting it later.
Okay.
Just in case.
Just letting you know.
There you go.
Okay, bye. Alright. So we've been doing equations, right? Where we say, let's do solving inequalities, is what our lesson's going to be now. Right. So we've been doing equations where, like, the basic of it is like 6 equals like 12 over 2. Yeah, this is an equation. The thing is equal to a thing. But in an inequality, everything is greater than or less than, right? So 6 is greater than 5. 6 is less than 7, right?
Yeah.
Now, what's interesting with these is you can do, and so we've taken this thing, and we've done, if 2x equals 12, right? We use the equation with algebra, and we solve that x equals 6 using that, right? But you can actually do the same thing with inequalities. It basically says that instead of a single answer, your answer is basically x is any number greater than or less than a certain number. Okay? So if I said here, if instead we did 2x is greater than 12, okay? And I said if x is 0, that's false, because 0 is not greater than 12. If x is 5, it's false, because it's 10. If x is 6, it's also false, because it's greater than.
Yeah.
If x is 7, it's 14, it's true. That's also true for x is 8, right? 16 is greater. And x is 9, and x is 200, and x is 1,000. Basically anything bigger than 7. Right? Actually, 6.1 will work as well, because 12.2 is greater than 12. So anything bigger than 6 will be correct for this equation. So what we do is it's similar. We solve it a similar way. We treat this like it equals, okay? And we divide by 2 both sides. Whatever you do to one side, you do to the same thing to the other side. Okay? So divide by 2. Now x is greater than 6. So this will be true. Yeah, this will be true. 2x greater than 12 will be true for every value of x greater than 6. So now instead of one answer, it's a range. And you write it like this: x is greater than 6. Any number greater than 6 will make this inequality true. That's basically, we solve them the exact same way we solve equations. You do the one side, you do the other side. You subtract, you multiply, you multiply. But in the end, we're going to get, instead of x equals something, we're going to get x is greater than or less than. Okay? Now there's another symbol that comes in here. And that is, say we have 3x plus 5 is less than or equal to 14. So because it's algebra, we have a variable and we don't know what it is. So what we're saying is it's either less than or equal to. It can be either one. Okay? So we use this inequality and we can say whatever our x is, it has to be less than or equal. So we solve it the same way. 3x, we subtract 5 from both sides. Okay, so this is 3x is less than or equal to 9. We divide each side by 3. Therefore, x is less than or equal to 3. Okay, so you do, for less than or equal, you do the less than sign and you do another line underneath it. So it's kind of like a combination of less than and equals. We squish them together, right? They become this. And then greater than or equals becomes, no, this is not clear. Becomes greater than equals. Right? This is how we write them. Less than or equals, greater than or equals. Or less than, greater than. Or just plain equals. But we can test this. X is less than or equal to 3. So let's say it's greater than 3. 4 becomes 12 plus 5 is 17. It's not correct. It's not less than or equal to 14. If it's 3 itself, it becomes 9 plus 5, 14. That is correct because it equals 14. If it's 2, it becomes 6 plus 5 is 11. That's correct because it's less than 14. So anything that's equal to or less than 3. Mechanically, it's pretty much the same thing you've been doing for equations. So it's not really much more, much more skill. It's not really a new skill. It's just applied in a slightly different way. kind of a conceptual understanding of like greater than or less than. Are there any questions about this? Okay. Then there's a very important rule. Let's take a picture. And the important rule is, for inequalities, there's one difference. And that is if you multiply or divide by a negative number, you change the direction of the sign. Okay? Kind of because the number is like a change, like a negative number is a change, so you change it as greater than or equal or less than. Because if you are multiplying 1 by negative 1, right? Anything that's like less than 1 now becomes greater than negative 1. It's kind of like this flip. So if you multiply across, so let's do an example. Minus 2x is greater than 5. Okay? 3 minus 2x is greater than 5. So when we first of all we subtract 3 from each side, so we get negative 2x is greater than 2. Right?
Yes.
Now we're going to divide by negative 2. Okay, so we divide by negative 2. Divide by negative 2.
1.
Alright? So we're dividing by a negative number. So we flip the sign.
Yes.
Alright? So this becomes x. This one's greater than is now less than negative 1.
Yes.
And that's the key. Whenever you multiply or divide by a negative number, you flip the sign. And we can check it. You might be like, that's weird. It does seem weird. To me, even seems like magic. But we'll see. Alright? Minus 1. Okay. Let's say x is greater than minus 1. Let's say x is 0. Right? If x is 0, this is 3 is greater than 5. It's not true.
Not good.
Right? If x is 1, 3 minus 2 is 1. It's not greater than 5. If x is 2, it's 3 minus 4. It's minus 1. You see it's getting smaller and smaller, more and more negative. So for every number that's greater than minus 1, this here gets smaller, so it doesn't work for minus 5. Okay, let's see, x is minus 1, so it becomes 3.
3.
3 plus 2 is 5. If 5 is not greater than, it's equal to. But say 3 is less, x is less than minus 1, so x is minus 2. Minus 2 times minus 2 is 4.
It's 4.
3 plus 4 is 7, it's greater than 5.
It's greater than
Alright?
5.
Say it's minus 3, anything less than. Minus 3 is minus 6, 3 plus 6 is 9, greater than 5. So you can see every number less than minus 1, this one is correct. And it wouldn't have been correct if we hadn't flipped the sign. And if we hadn't flipped the sign, it would be x is greater than minus 1, but that wouldn't work. That's why you have to flip the sign when you multiply by a negative number. And part of the reason you can think about it is when you multiply, right? When you multiply by a negative number, you're flipping the sign anyway, right? A negative 1 becomes a positive 1. A positive 1 becomes a negative 1. So we're just doing the same flipping to the sign, to the greater than or equal sign. We change it. Let's do another example. Let's do 3 x is greater than let's not do 3. Let's do 15 over x is greater than negative 3. Okay? 15 over x is greater than negative 3. So now we want to get x onto this side, right, and negative 3 onto this side. So we can do 15 is greater than negative 3 times x. We multiply both sides by x, right? And we divide both sides by negative 3, so that's going to become negative 5
Negative 5.
less than
X.
because I divided by negative 3. Divided by a negative number, I change the sign, right? Or, let's see, try this one. Here, negative 2n minus 5 is greater than or equal to 3. So we have a greater than or equal sign. Okay, greater than or equal to 3. So first we need to add 5 to both sides, right? We have negative 2n greater than or equal to 8. Right. Now we divide by negative 2, negative 2. So this becomes n, sign changes,
Yes.
and this is negative 4. Right? N is less than or equal to negative 4. If you look at this, negative 4 times negative 2 becomes 8. 8 minus 5 is 3. It works since less than or equal to, so it's fine. Less than negative 4, which is negative 5. 2, negative 2 times negative 5 is 10. Minus 5 is 5. 5 is greater than 3, so it works. So it's the same techniques. You just have to remember if you multiply or divide by negative to change the sign. Okay. Take a picture, and then there's one more thing to show on this one. And then move on to quadratics. What if you have minus 5 is less than or equal to x plus 3 is equal to 4. A double. X is somewhere in a certain range. Okay? So this is saying it's not just greater than and keeps on going to infinity. It's less than something and bigger than something else. And you can write that this way. So actually saying this here is less than or equal to or greater than or equal to. And what you do with this one is you separate it out into two different inequalities. Okay? So I take it as if it's two different problems. So this one becomes minus 5 is less than or equal to x plus 3. Because no matter what, that has to stay true, right? I've written this thing here. And this one, I write as x plus 3 is less than or equal to 4. Okay? So that means over here we solve it, subtract 3 from both sides. We get minus 8 less than or equal to x. Or x is greater than or equal to minus 8. Either you can write it either way, just make sure that the greater than sign stays in the same way, on x the same way. If you put it to the other side, the greater than sign is still there. Right? And this one, we subtract 3, right? So you get x is less than or equal to 1. So since we have here, we can write this as minus 8 is less than or equal to x, which is less than or equal to 1. So that means x is somewhere between minus 8 and 1. It's a way of expressing the range. It's somewhere between minus 8 and 1. That's how we're writing this. And when you see a problem like this, you just take it into each one. It seems a little weird because it seems like you're doubling this thing. But you're not, because you're going to come back with an x in the middle. Any questions on that?
Yeah, if you have another example like this.
Yeah, I'll do another example. Let's say we have 2 is less than, no, let's not do 2. Let's do 6 is less than 2x on, 5 is less than 2x minus 1, which is less than or equal to, does it have like, yeah, I do. X plus x plus 7. Okay? So we have 5 is less than 2x minus 1, which is less than or equal to x plus 7. Okay? So we do it two ways. First of all, we do x, 5 is less than 2x minus 1. Right? And we can solve this. We add 1 to each side. So it becomes 6 is less than 2x. Divide by 2. 3 is less than x. Right? That's this side. Then we do this side. We have 2x minus 1 less than or equal to x plus 7. Okay? So we add 1 to each side. We get 2x less than or equal to x plus 8. Subtract x from each side. X is less than or equal to 8. I'm subtracting x. Pardon? Because I had x here. Right? I had x on both sides. So subtract this one so it can come here. Right? So subtract, first I added 1 to get rid of this. Now I need to get the x over here. So subtract x. Now x, the symbol stays the same. I'm not multiplying. So x is less than 8. So x is greater than 3 and less than or equal to 8. So the answer is 3 less than x less than equal to 8. Okay? You see? You basically just take each side. Whatever is here, you solve it. Whatever is here, you solve it. Then in the end, x will be in the middle. So it actually helps to keep it this way. Any questions? Alright. I'll take a picture. Next section. Quadratic equations. So up until now, we've been solving for variables where the variable has only one power, right? The quadratic equation is now where you have the square. Okay? So this is another level, it's another step. So now we're going to do, what if you had squares? Like that. How do you solve for y? And there's a very specific a very specific kind of equation called a quadratic equation, which has the format of this. Something x plus a. Let's say, like, actually, the quadratic equation has ax plus b times cx plus d equals 0. That's your standard way of writing a quadratic equation. Okay? That's the standard way. Commonly, it's something like this. X plus 1 times x plus 3 equals 0. Okay? And what will happen is, you can write these out, you can simplify these. And so this is the equation. The quadratic itself, the quadratic expression, doesn't need to have the equation part yet. This is just the quadratic expression. Okay, the quadratic expression doesn't equal 0 yet. It becomes an equation when you put it equal to 0. Okay? So this is a quadratic expression. And you guys have already learned how to simplify these, right? We did this one already. So how would I write this out?
X squared.
So first we do, there's a rule, it's called FOIL. Okay? first outer inner lost. Okay? So here's the first one, multiplied by the outer one. So the first one's first, then comes the outer, then the inner, then the lost. Okay? So x squared, then we do outer,
3x
plus 3x, then we do inner,
plus x
plus x, and then we do lost,
plus 3.
plus 3. So that's a first, outer, inner, lost. That's FOIL. Do that again. First, outer, inner, lost. Right? Let me do it with colors. If I have it. This one here? Nope. Alright, so that's F. That's O. That's pi. And that's L. Alright? First, outer, inner, lost. Now we already practiced this one, so it's I think you guys know how. So then we have this x squared 3x plus x plus 3, right?
Yeah.
Sorry, x squared
Plus
plus
4x
4x
plus 3.
plus 3. Okay? So this is you are writing your quadratic expression. So one of the things you'll be practicing is converting this into this. Okay? Let's do another practice one. 2x plus 3 times x minus 1. So first is what?
2x squared
So 2x squared.
minus
2x squared. Then we do the outer.
yes. Minus 2x
So minus 2x. Then we do the inner.
plus 3x
Plus 3x.
minus 3.
And then the lost. Minus 3. Okay, and then we need to add these up. So minus 2x and 3x becomes what?
No, x.
Minus 2 and plus 3.
X
X, that's right. So 2x squared plus x minus 3. You see here? That's how we solve it. That's writing these expressions. Let me try one more. X minus 4, x minus 3. Okay?
x squared
X squared
minus 3x
minus 3x
minus 4x
minus 4x
plus 12.
plus 12. Minus 4 times minus 3. Yeah, that's the tricky part with the two negatives. That's why I did this way, this one this way. And what does that equal? X squared
X
with
plus
minus 3x minus 4x
minus 7x
minus 7x
plus 12.
plus 12. So you see here, minus and the minus end up with a plus here, but a minus over here. So this is basically how you solve these out. Any questions on quadratic expressions? Good, because that's the easy part. And now we're going to do the equations. Well, first, actually, before we do the equations, we need to do what's called factoring. So we need to go the other way. Alright? So, say I have x squared plus 2x plus 1. And now I want to write it as in this format. So to go backwards. This is a challenge, right? You have to think about the problem. But what you have to think about is, first of all, I'm going to have x's here, right?
X here and X here.
And then you decide, are there any coefficients for this one? In this one, there's not, because x squared doesn't have a coefficient. So automatically, if there's no coefficient here, you know there's no coefficients here, right? Because these two multiply to become this. You're kind of going backwards. Secondly, this one here is whatever this is times this, right? So this times this,
1.
1, right? There's only one way to get two numbers multiplied to each other to equal 1.
Plus 1, plus 1.
So it's 1 here and 1 here. Right? And then the question is it minuses or pluses?
Pluses.
And that you determine by here. What's in the middle, right? Because this plus this is the middle. Right? So it's plus. Time to go backwards. And you can check it. X plus x is x squared. Plus x is 2x plus 1. Right? So this is factoring. Is it called factoring? Yeah, factoring. This is factoring quadratics. But now, you may have something more difficult. Alright? What if we have x squared? Let's see. That one is plus x minus 2. Okay? So we have x squared plus x minus 2. So we write it again like this. First thing we know is no coefficient here.
Yeah.
So it's x and x. Secondly, we have 2 here. Right? So for a number to be 2, it has to be 2 times 1.
Yeah.
Right? So it's 2 here and a 1 here, let's say. Right? But it's a minus, so one of them is negative and one is positive. Alright?
Yeah.
So then we say these are going to add together to get this one. Alright? So 2 and 1. If the 2 is negative, this would be a minus 1, right? And if the 2 is positive, this would be a plus 1. And here we have plus 1x.
2 is positive.
So it's plus 2 minus 1. You see that? This is another of those takes a lot of practice.
I did just see.
Right? I remember when I was learning these, it's kind of like got to a point where you sort of get an intuitive sense of it just from practicing it. And if we can do it out, we can see x is x squared, right? X that's minus x, the outer. Inner is 2x,
Yes.
and lost is minus 2.
Minus 2.
And these two become x squared plus
Plus
x
x
minus 2.
minus
You see? Which is this one. But it's difficult to go this way. Right? It's difficult to factor them.
Yeah.
So you're going to have a lot of practice factoring them. Now I'm going to spend the next 10 minutes giving you examples so you can see what I'm doing. Okay? But before we do that, there's one last part of this, which is if I said x squared plus x minus 2 equals 0. Now it's a quadratic equation. Alright? And I have this. But the problem is I can't solve for x here. Right? I could put 2 on this side, but then I still have a problem.
Yeah.
Right? I still have a problem, which is that if I put 2 on that side, say I try that, x squared plus x equals 2.
Equals 2.
Then maybe I can divide through by x, right? So I get x plus 1 equals 2 over x. That doesn't work. Does it? Like, how do I get x by itself? I can't get x by itself. It's a problem. However, if I factor this, like that, I can write them as x plus 2 and x minus 1 equals 0, right? Now that means if either of these equals 0, it will be true, right? Because anything times 0 is 0. So we have two solutions. That's the thing for a quadratic. Whenever you see a variable squared, it means there's at least two solutions. Okay? So, the solution is x plus 2 equals 0 and x minus 1 equals 0. Because either value of x, which makes this true, will make the whole thing equal 0. Right? Because this thing, if this is 0, doesn't matter what this is, it'll be 0. Right? So we can solve for each one. Therefore, x equals minus 2 and x equals 1. So there's two answers. X can be either minus 2 or 1, and you'll get 0. And if you're not sure, you can check it. You have minus 2, right? Minus 2 squared plus minus 2 minus 2, right?
Yeah.
So this becomes 4 minus 2 minus 2 equals 0. Check.
True.
You see that?
Yeah.
Okay, now let's try the next one. It's 1 squared plus 1 minus 2 becomes 1 plus 1 minus 2 equals 0. Check.
Yeah.
You see that?
Yes.
Both of those answers are true
True.
for this equation. No other x's will work, but these two, minus 2 and 1, work. But you have to factor, you have to use your factoring in order to get to this stage. That's why we're factoring these quadratics. You might be thinking, well, why am I doing this? Because it's so you can solve more complex equations. Alright? Let me do some examples. Next 10 minutes. Let's say I give you x squared plus 7x plus 10. Factor. Okay, so the first thing is you write your 2 here, right? First stage, we look at the x. There's no coefficient. So that immediately tells you it's just x and just x. Second, we look at the other end. What two numbers multiplied equal 10?
5.
5 and
2.
no other numbers, right?
Yeah.
If there are the numbers, then you have to sometimes think of both of those options. But here it's 5
Yes.
and 2. All right.
Positive.
They're both positive, because this is positive. They're either both negative or both positive. Right? Because if it's minus 5 and minus 5, you still get positive 10. But if it was minus 5 and minus 2, this one would be negative. But it's positive, so we know it's plus and plus. Okay? And if this was an equation, pardon? Because there's a positive here and a positive here. Because these two numbers multiply together this. So they're either both positive or both negative. If they were both negative, then x times 2 and x times 5 would be 5x and 2x. But if they were both negative, it would be negative and a negative, so it would be negative 7. But because this one is positive, I know that they're both positive. Okay? Let's try another one. So and if this equals 0, right, then x would be minus 5 or minus 2. Let's say x, if it equals 0, right? Let's say x plus 5 equals 0, so x equals negative 5. Or x plus 2 equals 0, so x equals negative 2. Because either one times, any number times 0 is 0. So all I need is one of these to be 0 for the equation to be true. So I can separate them out like that. And most of the stuff you're doing is just the factoring. Once you get the factoring, solving for x is easy actually. Because then it's just an individual one here. Let's try another one here. X squared minus 4x plus 3. So the first thing we do, this is our coefficient here. So we can do x. Okay? Then 3 is here. Right?
Yes.
So it's 3 and 1.
Plus 4 minus. No,
Yeah, this is it. Negative. It has to be negative and negative. Because this is minus 4.
Yes.
Right? So it's a minus and they're adding. 3 and 1 is adding to 4. So but it's a positive here. So it has to be negative and negative.
How do you get this 3?
Because what times itself, what two numbers multiplied equal 3?
This one is, I think it's 4, right?
This is 4. No, this is not 4.
Okay.
Because the end number
Yeah.
is this times this. Okay, so whatever this number is here, it has to equal this times this.
Yes.
Always. Okay? And whatever this is has to be this times this. So you always know kind of these ones and these ones. But you figure out the rest based on
Yes.
the middle. And if you have a positive here and a negative here, it's probably is going to be at least one negative. No, if it's a positive here and negative here, they're both going to be negative. Must be. Because otherwise this would be, if one of them was positive and one was negative, this would be a negative. So if you have a positive here and a negative here, they're both negative.
Well, yes.
If you have a positive here and a positive here, they're both positive.
Yes, both of it.
If you have a negative here and a positive here, then one's negative and one's positive.
Yes.
Okay? So let's try another one. X squared plus x minus 6. I had to prepare these ahead of time to make sure they worked. I couldn't just come up with it in my head. Alright, x squared plus x minus 6. So again, we'll go here. X and x, because this has got no coefficient, right? I'm going to give you one of these coefficients next. And here it's 6. What two numbers equal 6? It could either be 2 and 3, or it can be 1 and 6. Don't ever discount that it can be always 1 and the number itself. Okay? But you think it's 2 and 3? Sometimes what you do is you try it out.
Plus 3 minus 2.
So you have 3 and 2. Okay?
Yeah.
And so this is a minus and a plus. So that means 1 is negative and 1 is positive.
3
Right?
is positive.
3 is positive because this is positive here.
Yeah.
Whichever one's bigger. If this is positive, whichever one's bigger.
Yeah.
Right?
Why we don't use 1?
Pardon?
1 and 6.
Why not 1 and 6? I can try. There's going to be some trial and error. Six and 1. Okay? So then we're going to know this is one of them's positive and one's negative. So it's going to be a difference between 6 and 1, right? What's the difference between 6 and 1?
5.
5. Or it could be plus 6 and 1, which would be 7.
7.
Right? But it's not, it's 1.
Yeah, there is 1.
So here we have a difference between them is 1. So it must be this one. But you're right. Sometimes you'll do that. You'll try this one and you'll say, it's not working. So you have to try a different one. Because you won't necessarily get it right the first time. Don't give up. Try the next combination. Okay?
Minus 5. 4.
Yeah, so it could be like 5, 6. Because if this one it was like plus and minus, it would be x squared minus 5x.
Yes.
No, plus 5x.
Plus
Minus
5,
6.
Minus 6.
Yeah. Let's try oh, I'm sorry. Shouldn't have done that. Oh well. of this. Try 2x squared plus 3x plus 1. Alright. So now we have a coefficient on the x, right? So it's actually the same thing we do here. We say what two numbers multiply to equal 2?
1 and
2 and 1, right?
Yeah.
So let's just say one is 2x, the other one is x, right? Because these will then multiply to equal each other. And over here we have a 1, right?
Yes.
So what numbers multiply to equal 1?
1 times 1 and minus
1 and 1.
Yeah.
So it has to be 1, it has to be 1. Now you decide if it's pluses or minuses. It's plus, so they're either both minus or both plus, right?
Both plus.
Both plus.
Yes.
You can try, and you can do some trial and error. Try each one, right? Let's just see, this is 2x squared, and then outer is 2x, inner is 1x, is 3x, that makes sense, and last is 1. Yeah, so it's this one. It's a lot of just kind of like trying it. But like I said, you put the brackets, you put, first of all you do this one, and then secondly you do that one, based on these two. And then you figure out the rest from the middle. It's kind of like a problem solving. It's like a riddle. So like a math riddle, these things. Let me do one more like that. Actually, let me do another one like this. X squared minus 1.
X
So
minus
you can do
1.
this. Right? X and X, right? And this was 1 and 1.
Minus 1 plus 1.
Yep. So they'll cancel. So don't be alarmed if you don't see something in the middle. Sometimes they're canceling each other out. Right? It'd be the same if I did x squared minus 4. Right?
Yeah.
It'd be x minus 2, x plus 2. Right? So something of this format usually has the exact same but negative, positive. Alright, one more difficult. 4x squared plus 8x minus 5. Okay? So first we have here,
2x.
let's try 2x, yep. 2x, and here's 5, right? So 1 and 5. Okay? And now it's a negative, right? So one must be positive and one must be negative. Which one do you think will be positive? 5. The 5, because this is positive, right? So plus, and this will be negative. Let's check it. This becomes 4x squared. This times this is minus 2x, right? 5 times this is plus 10x. 5 and 9 is minus 5. Yeah, and that equals this. You see it? It looks, you look at this, you're like, oh my goodness, right? But then you just remember your steps. Right? You first do the x's, then you do the n's, and then you figure out the plus and the minus based on them. I think you guys can do this. Alright, go home, have some homework. I'll give you Khan Academy. If you struggle with it, we'll go over it next week. Alright, so homework is these 2 pages we did. So page 259 all, and page 359 all, and 361 all. Okay? Have a great week, and good luck.